Okay dude, so in this video we are going to do the second exercise of rational numbers. So before I start this exercise, there are three concepts which you need to know. Yeah, the first one is terminating decimal, the second one is non-terminating decimal, and the third one is a recurring decimal. Okay, so what are the meanings of these three things? So wait, one. So a terminating decimal is a decimal which finishes. So what do I mean by that? That it finishes. For example, suppose 0, after doing 2 by 10 you get 0.2. Understood? 0.2. So this is a terminating decimal. After doing 625 by 1000 you get 0.625, which is another terminating decimal. Why? Because there is nothing after 5, there is nothing after 2 over here. Yes, so these are what you call terminating decimals. Okay, next we come to non-terminating decimals. I'll write it as NT. Non-terminating decimals means what? The ones which do not finish. For example, 0.234667. Yes, so and then it keeps on continuing. Okay, wait 1 minute. Sorry dude, I had to go out for a while. So this is what I was explaining. Non-terminating decimal is something which doesn't end, like this 0.23467, then 8329. This decimal is only continuing. This 8329 is not a new decimal. Okay, 8329456 dot 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 dot, and it keeps on continuing. Yeah, like a decimal which doesn't end. That's what you call a non-terminating decimal. Okay, then the next concept is that of recurring decimal. Recurring decimal, we are going to write it as RD over here. What is a recurring decimal? Which follows a particular pattern. For example, 0.3333. Yes, so this is a this is this is this decimal has a pattern key. It it has got 3 3 3 and 3, and then it keeps on continuing 3 3 3 dot 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 dot. Understood? This is what you call a recurring decimal. Okay, next, another, let me give you another example of recurring decimal. So 0.323232 dot 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 dot. What is the pattern over here? 32, then 32, then 32. 32 is the pattern over here. So this is another recurring decimal. Okay, next we have 0.625625 dot 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 dot. Yes, so here what is the pattern? 625 and then again 625. This is the pattern over here. Understood? So, and there are two conditions for a recurring RD. There are two conditions. Number one, it needs to follow a pattern. For example, 0.3232 and then 32. What is the pattern over here? That it follows this pattern called 32. Yes, and what is the next thing? This is the first condition, number one condition. And what is the second condition? That it needs to be never ending. Never ending means what? It is got to be dot 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 dot. Understood? So all recurring decimals, listen to the statement carefully, all recurring decimals are non-terminating, means they don't end, plus they follow a pattern. So what is the difference between a non-terminating decimal and a recurring decimal? First, let's talk about the similarity. The similarity is that, wait, there's a dog barking. Yeah. What is the wait dude. Yeah. So what is the similarity between a recurring decimal and a And wait, this dog is not stopping. It's okay, dude. So what is the similarity between a recurring decimal and a non-terminating decimal? The similarity is that both of them don't end. Like both of them have this dot 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 and dot at last. Means both of them are never ending. But the difference is that a non-terminating decimal doesn't follow a pattern. Understood? But a recurring decimal always follows a pattern. 3 2 3 2 3 2, then 6 2 5 6 2 5. It always follows a pattern. Okay, so now we will straight away jump to the sums. What does the first, let's read the heading. Without actual division, find out which of the following rational numbers are terminating decimals. So you are supposed to find out that whether these decimals which you see, whether these fractions, after dividing every fraction you get a decimal. Yes, so you need to find out that whether these fractions will give you terminating decimals or non-terminating decimals. Okay, but the thing is that without actual division means you can't divide and show it to the teacher that yes, this one is, for example, let's look at the first one is 13 by 80. Yes, if we divide this, 1 minute, 13 divided by 80 is equal to 0.1625. Okay, so this one after division we see that it is a terminating decimal, means it ends. Okay, but we can't do division on paper. So how are we supposed to figure out that whether this is a terminating decimal or a non-terminating decimal? Yes, so I'll show you that. So the fraction which we have is 13 by 80. Okay, so what we are going to do is we are going to prime factorize the denominator. Okay, so if we prime factorize the denominator, it becomes 2 40s are, 2 20s are, 2 10s are, 2 5s are, 5 1s are. Okay, so how much does this become? This 80 becomes 2 to the power 4 into 5 to the power 1. Yes, so this one is a terminating decimal. Now why do I say that this one is a terminating decimal? So this is the condition. What is the condition? That if after prime factorizing, listen to me carefully, if after prime factorizing the denominator of a fraction you get 2 to the power something into 5 to the power something. Yeah, if you get 2 to the power something into 5 to the power something, yes, then it is a terminating decimal. Okay, for after this we'll move on to the second sum. Sorry, we won't do the second sum, we will do the odd number sums. Okay, so the third sum we will do. Third sum, the fraction is 5 by 12. Okay, so let's do this 5 by 12. So the fraction which we have is 5 by 12, and we are supposed to find out that whether it is terminating or non-terminating. Yes, so we will prime factorize 12. 3 4s are 12. Okay, so it is 3 into 4. Yes or no? Yes, so this has got, okay, sorry, 1 minute, I'll have to erase the whole thing. It is 3 by 12, or was it 3 by 12? Wait, 1 minute. It is 5 by 12. Okay, so it was 5 by 12. Yes, so we will prime factorize 12. 3 4s are, 2 2s are, 2 1s are. So how much does it turn out to be? It is 3 into 2 to the power 2. Yes, so the condition was that you need to have a 2 and a 5. Okay, but this one has got a 3 instead. Yes, so this one will turn out to be a non-terminating decimal. Okay, means never ending decimal. Now we will actually verify this in the calculator. Yes, so 5 divided by 12 is equal to, as you can see, it is a never ending decimal. Understood? Next we are looking at number 5. Yes, 16 by 125. So let's first write down the fraction 16 by 125, and then we will prime factorize 125. Okay, 5 2s are 10, 25. Yes, 5 5s are 5 1s are, that's it. So it becomes 5 to the power 3 only. Understood? 5 to the power 3 and 2 to the power nothing, 2 to the power 0, because there is no 2 only. Still this one is a terminating decimal. Understood? So this is a new thing which is coming up in front of you, that if it is suppose only 5, then also it will be a terminating decimal. If you get something like after prime factorizing the denominator, you get suppose 2 to the power 3. Suppose you get 5, you get the decimal 5 by 8. After prime factorizing 8, how much do you get? 2 4s are, 2 2s are, 2 1s are, you get only 2 to the power 3. Yes, so this one is also a terminating decimal. Why? Because it is 2 to the power 3 into 5 to the power 0. When there is no 5 or there is no 2, still it will turn out to be a terminating decimal. Understood? So we move on to the next sum. Let's read the heading of the next sum. Write each of the following in decimal form and say the kind of decimal expansion it has. Yes, so we are supposed to find out that we are supposed to divide these. Like here they haven't mentioned that without actual division, so we can divide this, and we need to tell what kind of decimal will they form. For example, the first one in front of us is 5 by 8. Okay, we need to say that what kind of decimal is it? Terminating, non-terminating? If non-terminating, then is it recurring? Yeah, so we need to say that. How are we going to do this? We are going to actually divide this. Understood? So from the previous one only, it is 8. 8, you know, it is 2 to the power 3, so it is going to be a terminating decimal. Yes, but you need to, as you can see the answer over here, you need to mention the exact decimal, so you need to divide it. Yes, so the first one I am going to do it for you on the board. Yes, the rest of it I am going to show it to you on the calculator, and you are going to do it on your own. Yes, so the first one is what? First one is first one is 5 by 8. Okay, so 8 with 5 within the box. 8 zeros are 0. 5, you put a decimal over there, 0. Yes, 8 6 are 48, and then what remains is 2. Yes, then because of the decimal a 0 comes down, so 8 2s are 16, after which what remains? 4. Yes, because of the decimal another 0 comes down. Wait, I'm not being able to show it to you over there. Because of the decimal another 0 comes down. Yes, so it will be 8 5s are 40, and finally it gets over, no remainder, so 0.625, and that's it, it ends. So what kind of a decimal it is? It is a terminating decimal. Okay, so now we look at the third kind, third sum, which is 3 by 11. Okay, so the first thing which you are doing in this sum is that you are thinking mentally that I have already told you the rule that how are you going to figure out whether it is terminating or non-terminating? By prime factorizing the denominator. Yes, so you are going to think it out mentally. In this sum, it is not necessary to write it as 2 to the power 3 into 5 to the power something, because they haven't asked for it, but you are going to do it mentally. Why am I asking you to do it mentally? That I'll tell you later on, because anyway you're going to decide, you're going to divide. Yes, but still you need to know it mentally, that whether it is a terminating decimal or a non-terminating decimal before you start dividing. Understood? So why am I asking you to do it? That I'll tell you later. Yes, so 3 by 11, the thing which you see on the screen, 3 by 11. Yes, so this is a, 11, you can't prime factorize it, so it is, so 11 is 11 to the power 1. Yes or no? It is 11 to the power 1. So it doesn't have 2, it doesn't have 5, means it is non-terminating. Yes or no? Now you are going to calculate it. You are going to divide and check that how much is 3 by 11. So 3 divided by 11 is equal to 0.2727272727. So in the answer, what are you writing? In the answer, first of all, you are writing non-terminating. Yes, and after that you are going to write recurring. Okay, so it is a non-terminating recurring decimal. Understood? Because first of all, it is never ending. Yes, and second of all, it has got a pattern. Okay, so as you can see, the answer given over here is 0.27 non-terminating recurring decimal. Understood? Now we get to sum number 5, which is 11 by 24. So first, in the rough work, you will figure out that whether it is terminating or non-terminating. 2 12s are, 2 6 are, 2 3s are, 3 1s are. Yes, so it is 2 to the power 3 into 3 to the power 1. So it is a non-terminating because it has got 2, but it has also got 3, which doesn't satisfy the condition. Yes, so it is non-terminating. And then you will actually divide. So if you actually divide it, what are you going to get? 11 divided by 24 is equal to 0.458 and then 3333333. So what are we going to do in this? So this doesn't have a pattern initially, but after that it has a pattern. I think it is going to be this thing only. What do you call it? Non-terminating decimal, because it is never ending. But I don't think that if we are going to call it as a recurring. Let's check the answer. Number 5, the answer is okay. So number 5, the answer is non-terminating recurring. Understood? So even if there's a pattern at the last, like here there was a pattern at the last, 0.58 and then 33333. So this one also you will write it as NT, means non-terminating. I am writing NT, you will write full form NT recurring decimal. Understood? So just check the way how they have written. Yes, so this one, number 5, just check the way how they have written non-terminating recurring, and 0.58 they are not writing 333333. Above 3 they have just put that dash. Okay, now I want you to look at sum number 4. See, this is why acha, leave it. Yeah, so sum number 4, see, you won't understand. Like normally we leave it after 2 or after doing it. Like in this one you're doing it at least till 5 places. Okay, like the divisions, you're not going to leave it like first after dividing. Suppose you get the answer as 0.623, and then you don't see that whether it happens again or not, whether 0.623 happens again or not, then it is going to be a big problem. Understood? So you are going to, in these kind of sums, you are going to divide at least till 6 places. Yes, sixth number. Like for example, in this one, it, like, I don't know how many times you'll have to divide to get to the fact that it starts recurring after 615. Understood? So the decimal looks somewhat like this: 0.384615. After that it starts recurring with 384615. So it is difficult to this thing, to understand these kind of sums in the exam, because you go maximum till 6 places. Suppose you divide it and you get till 615, and then you think, then you see that it is not recurring. Yes, but it actually starts recurring after that, so it is very difficult. So you need to take these chances in the exam. In the exam you are not going to do it till the 7th place and the 8th place to check whether it is actually recurring or not. In the exam you are doing it maximum till 6 places, and after that, if the teacher gives this kind of sums, then you're going to lose marks, because no point wasting time in going till 7 to 8 places. Understood? After that we are going to look at this one, number 7, 231 divided by 231 by 625. Yes, so 625, if you prime factorize, you will get what, 5 to the power something, which means that it is terminating. Yes, and what is the answer? You, after that, after dividing, you will get 6525. Yes, so it is terminating and not recurring as well. Okay, then we move on to the next type of sums. The rest of it you're doing it on your own. We move on to the next kind of sums, okay, where they're asking you, okay, express each of the following decimals in the form p by q, where p and q are integers. Okay, so here you have got recurring decimals like 0.2222. This one, first one is 0.22222222, and that you need to express it as a fraction. How are you going to? So this is the most important type of sum in this exercise, and yeah, so let's do it.